bright future. Every student matters.
Continuing with this same particular thing, Newton related his ideas to all the planets and rather to all the things in the universe, and he concluded something which today we know as the universal law of gravitation. This universal law of gravitation was given by Newton, therefore, this is also known as Newton's law of gravitation. Now, first of all, let us try to relate what exactly is this Newton's law of gravitation. Newton said that any two objects in this universe, mind you, I am saying universe, not earth, not our solar system, but the whole universe, any given two objects, living or non-living, you sitting along with your friend, you and the table on which you are just studying, you and the house, right, me and my this particular setup, we all are included in it. No life living or non-living differentiation is made between it. So, all the things, any two objects in this particular universe, Newton said that they attract each other, right. So, now they are attracting each other. Let this be a first object and this is the second object, right. These can be any objects. Let the mass of the first object is m1 and the mass of the second object is m2. We can also differentiate it by taking capital M and small m, one or the same thing, right. So, let there be two objects having mass m1 and m2. Now, according to Newton, he said that these two objects are actually attracting each other with a force, and the force with which they are attracting each other is directly proportional to the product of their masses. If I am talking about the product of the masses of the object, that means it comes out to be m1 m2, or if you are taking capital M small m, it comes out to be capital M into small m. So, the force of attraction between any two objects in the universe is directly proportional to the product of their masses. And one more thing he said that is this force is inversely proportional to the square of the distance between them, and this distance is also taken to be along a straight line joining the midpoints of these two objects. So, if this be an object number 1, this be an object number 2, then the distance that we will be considering, that will be from the midpoints of these two objects and it will be along a straight line. So, let this be the distance denoted by small d. So, as per universal law of gravitation or Newton's law of gravitation, he said that the force is inversely proportional to the square of the distance between these two objects. Got it? Fine. So, these are the two things that Newton said in his universal law or Newton law of gravitation, that I repeat, any two objects, right, in the universe, they attract each other with a force which is directly proportional to the product of their masses and is inversely proportional to the square of the distance between them, of course, from the midpoints of these objects and along a straight line. Got it? Now, if I combine both these things, what I will get is F is the force is directly proportional to m1 and m2, the product of the masses, and I also said that according to universal law of gravitation, F is inversely proportional to square of the distance between them. So, if I try to combine these two things, what I will get is that F is directly proportional to m1 m2 upon d square. Got it? Now, we know that whenever we have to remove this sign of proportionality, and if we want to convert it into is equal to sign, then in that case we multiply this side with a constant which is known as a constant of proportionality. And in this case the constant of proportionality is taken to be capital G. So, if I am taking it to be capital G, then my whole equation becomes that f is equal to G m1 m2 upon d square, where m1 and m2 are the masses of the two objects, d is the distance between the midpoints of these two objects, f is the force acting on it, the force of attraction always, and capital G is a constant of proportionality. Now, this constant of proportionality is given a name, and this name is known as gravitational constant. This is given by the name gravitational constant. Now, the value of this G was calculated by Henry Cavendish, and he just calculated the value to be 6.673 into 10 to the power minus 11, right, and its unit is Newton meter square upon kilogram square. Now, this value, how did it come? It was calculated by Henry Cavendish, and this unit, from where this unit came, we can relate it. How? If f is equal to G m1 m2 upon d square, we can relate it by cross multiplying and shifting sides. F multiplied by this d square is taken above, it becomes f into d square upon this m1 m2, I will bring it here, m1 m2, this equals to G, right. Now, if I relate G, the units part, we know that the SI unit of force is Newton, multiply by this distance, the SI unit of distance is meter. So, I can relate it to be square of the meter divided by kilogram is the SI unit of mass of first object, again kilogram for the second. So, kilogram into kilogram is a kilogram square. So, this is the SI unit of gravitational constant, that is Newton meter square upon kilogram square, correct. This may be written like this, or we may also write it as Newton meter square and kilogram inverse square. This minus 2 represents, this is coming in the numerator, I can also write it like this, and it is a constant value, right. Most of the times this the value of G is given to us in the numericals while doing the numericals in the questions, right. Most of the times the value of G is given to us in the questions while doing the numericals. Otherwise, we need to remember that the value of G is this much, and this is 6.67 into 10 to the power minus 11 Newton meter square upon kilogram square. This is as per 2 decimal places, and there are few times when it is specified in the question. In that case, we will take it to be rounded off 6.7 into 10 to the power minus 11 Newton meter square upon kilogram square, right. Unless until it is specified, we normally take it to be 6.67. So, you need to remember it, even if it is not given in the question. As a student, you must know the value of capital G, that is the gravitational constant, right. Now, this particular formula f is equal to G m1 m2 upon d square, let us see a video representation with which you will be able to relate it in a better way as to from where this particular thing comes. I hope you will like this particular representation animated video we have got, with which you will be able to relate. So, we are studying about Newton's law of gravitation. So, this is what Newton's law of gravitation says, that every body in this universe attracts each other or every other body with a force which is directly proportional to the product of their masses and is inversely proportional to the square of the distance between them, right. So, mathematically if we try to relate, then consider these two bodies, let the bodies be A and B of masses capital M and small m respectively, such that D is the distance between their centers. Now, let there be a force F by which these bodies mutually attract each other. Then what Newton said was that the force of attraction between them is directly proportional to the product of their masses and is inversely proportional to the square of the distance between them. So, combining these equation 1 and 2, we have F is directly proportional to capital M into small m upon d square. This may also be represented by removing the sign of proportionality, converting it into is equal to, and then we multiply the right hand side with capital G, right. So, the whole equation becomes F is equal to capital G into capital M into small m upon d square, where capital M and small m we already have studied that these are the masses of the objects A and B respectively. F is the force of attraction between them and D is the distance between the centers of these two objects, right. What about G? This G is the most important part. G is the constant of proportionality, which is commonly called the universal gravitational constant, right. So, this G and the value of G we have already seen, that what exactly and how exactly we see the value and the SI unit. Now, it has been found that the value of this gravitational constant, it does not depend upon the masses of the bodies or the distance between the bodies or the medium between the bodies, right. So, this formula for gravitational force is applicable anywhere in the whole universe. Means this particular value of G, not only this G is a constant value throughout the universe, but this particular formula for force or F, this is applicable everywhere in the whole universe, right. So, this particular formula states that any two objects in the universe, they basically attract each other with a force which is given by this particular formula. All right. Let us hope you must have enjoyed this activity and you must have understood what exactly the force of attraction between two objects in the universe is and how we are going to calculate it, right. Now, from this particular formula that we have given, we have seen that F initially is directly proportional to the product of the masses. That means, when we are talking about heavier objects, then in that case the force of attraction between them will be comparatively more as compared to that of the small objects. Similarly, when we are talking about the second aspect, that force is inversely proportional to the square of the distance, that means the more farther the objects are, the lesser force of attraction they will exert on each other, right. Now, based on these two things, we can very well now relate as to why Earth does not seem to be moving by the force of attraction exerted on Earth with a stone or a ball. Similarly, we can relate it in the case of Moon also, that Earth is much heavier as compared to Moon, number 1, right. Number 2 aspect is that the distance between Earth and Moon is also comparatively quite large, because of which the attraction of Earth on Moon is seemingly it's visible, but the attraction of moon towards earth, that basically the earth does not move towards moon. Got it? So, this is how we relate this basically force and the universal law of gravitation.